Welcome to Reality Creative Video. I'm Hermes, and today is the long-awaited video on making colloidal copper. Now, the reason for the long wait is copper is tricky, and I had to get my process down to something that I really absolutely like. I mean, sure, there's a simple way of making copper, but we're not going to cover that. You can find videos on the simple way of making copper. The copper I'm going to teach you how to make is going to be exceptional copper. So it is a multi-step process. So this video is going to be shot in little segments here and there to go along with it. So now copper, I use copper for my sinuses and my allergies. But copper is a good healer for muscle and skin. Copper is very good for internal processes, especially if you're taking other colloidals. Copper will help metabolize the other colloidals into your system as if it didn't need help already, but copper will increase that a little bit more. So I find copper is good for, it's supposed to be good for the hair and the scalp, the face. All in all, it's a very good colloidal to take, though you don't have to take a lot of it. Roughly a teaspoon a day is all you need for colloidal copper. Now, the problem with copper, and the reason I'm making more copper, is this is my current batch of copper here. It doesn't last. No matter what I've tried, the most I can get out of my copper is 60 days. So only make what you're going to need to take. Don't overmake. Like, don't make a gallon of copper because it's not going to last unless you can actually consume a gallon of copper. So only make what you're going to be able to use for 60 days, because after 60 days, it's going to start falling out. You'll get like a light blue gel on the bottom of your containers. And once that starts happening, then it just cascades after that. And before you know it, you got a clear solution with a whole bunch of blue on the bottom. So what you have to do is just toss that stuff away when that starts breaking down. But copper is a relatively cheap metal, so you don't have to worry about the expense of it. So it's just the time to make the copper. So you're going to need copper rods, okay? Now you can search on Amazon for 99.99% copper rods. You're probably going to overpay for them, but at least you'll know that they're hopefully 99.99% copper rods. But to be perfectly honest, you could go to the hardware store and buy 12 gauge, 14 or 12 gauge copper wire. As long as it says copper wire on there, it's going to be 100% copper, because that's just what it is. All right, if it has something else on there on the packaging, aluminum or something, you don't want that stuff. But if it says copper, you could do copper. And if you prefer, you can go on to Amazon. It's still cheap, for a big spool of this copper stuff. Isn't that expensive. I don't know what the going price is offhand, but $10, $15, something like that for a spool of copper. And it'll last you a long time. So that's the copper rods. And you're going to use 2 copper rods that you're going to put in 500 milliliters of water. Like that. And like that. Okay. The copper rod I'm going to be using as an anode is this guy here, and I use him for everything. This is my go-to copper anode that I use for everything except gold. Gold has its own copper anode. So I use this copper anode for silver and magnesium and zinc and all the other stuff. What's for the anode? Okay, now you got 2 things on here. You got an anode and a cathode. All right. The anode is the negative of the power supply. That's the black wire here. Okay. And the cathode is the positive of the power supply. Now you can use anything from, I will say anything from a 12 volt power supply to a 40 volt power supply. I'll show you a picture. This is my go-to power supply. I'm using 37.5 volts. I happen to like that value. But you can get those bricks, 32 volt brick power supplies, and they will be at about, 38 volts, something like that. You can also use your silver rig. If you got a silver rig, you can use the silver rig. I'll show you a picture of one of these old silver rigs that I used to use. You can use that for your copper as well. So with that out of the way, all right. Now material is going to, the way colloidals work is you energize, the electrons will come off of the anode, and then they will be attracted. They will blast into the cathode and will actually melt the material off of the cathode, which then will go into the liquid. And you'll see we swirl the liquid around with a stirrer when I get to that part, okay? Okay, yeah, this is a little stirrer thing goes in here. When we get to that part, we mix the liquid. I keep it agitated to prevent the copper from attaching to the anode. We want as much copper to go into the solution as possible. We're not going to use any heat, no heat whatsoever for our copper process. And this is a two-stage copper process, which is going to give you... All right, the reason it gets a little complicated is because there are two kinds of copper. And depending on what stuff you use in your copper mixture is going to determine what kind of copper you get. Now, there's copper 1 and copper 2, and that has to deal with the amount of electrons in the copper. Now, copper 1 gives you a green color, and copper 2 gives you a cyan color. But the particle size is very different between copper 1 and copper 2. And they're different chemically. And I believe that a good copper solution includes both copper 1 and copper 2. Now, up until recently, I've had to cook two separate batches, one for copper 1 and one for copper 2, and then mix them together afterwards. But I have, Providence has shown me a better way, and this is the way I'm going to show you how to cook a copper 1 and copper 2 solution in one go in an hour. So that's what we're going to do. And that's what I recommend, that you follow my procedure here to the letter to get an absolutely exceptional colloidal copper. Now, you won't need a scale to weigh the copper rods because we're going to go by the color of the liquid, okay? When the copper reaches a certain color, you're going to stop cooking it, which is going to be basically... I'll get a better picture of this blue. It'll be this color blue you see there on that one I've already done. So basically, that takes about an hour. You'll see the process, all right? So don't worry. So you don't need to weigh the copper rods at all. But you're going to need to weigh the solution, the chemicals, household chemicals, that you need in order to create the copper 1 and the copper 2 solution. So you're going to need a scale for that. Now you can use... I have a 3-digit scale, as you guys know. But for your purposes, for copper, you can use one of these kitchen scales. They're relatively cheap. I think this was $10 or $12 to measure out the amount of your stuff that you need in order to make what I call the stock solutions. Now the reason, so if you can see here, we got citric acid and sodium citrate. This is a sodium citrate, and this is citric acid. Both of them you can get on Amazon. Surprise, huh? And then the reason we don't use the powders is because it's very difficult to get accuracy with the powders. Yeah, you can just toss the powder in, but we're going for accuracy and the right amount of the chemicals to give us the right amount of copper that we want. We want copper 1 and copper 2. So that's why we're going to make stock solutions. We're going to dissolve a certain amount of citric acid and sodium citrate in 100 milliliters of water. Normally I do 500 milliliters, okay, because I use the stuff quite a lot. But I don't think you need 500 milliliters, so I've redone the formula so that you can do it for 100 milliliters. And then you can reuse this the next time you have to make copper. So basically we're looking at, now you're going to take that and you're going to dump these things in here. So that's what we're going to do right now. Take this, put my little funnel in here, and we're going to dump the citric acid in my 100 milliliters of water. Now, citric acid is not easily dissolved. Oops. So you might have to shake this up quite a bit and make sure that you got no hard, no stuff left in the bottom here that hasn't dissolved. So I'm not going to sit here shaking and shaking and shaking. Okay, so we got that is done now. Now we're going to make our citric sodium citrate. We're going to do the same thing. We're going to put the powder in here. Sodium citrate dissolves a lot easier. You don't have to shake and shake and shake. It puts a lot less stuff. So I would shake these things for at least a minute, okay? At least a minute. Shake these things up and make sure that they're totally mixed, especially the citric acid. Okay, so we got our stock solutions now. Got our citric acid, we got our sodium citrate, and we're going to use that on the next part of the process, which is to make the actual colloidal. I'll be right back. Okay, now on to the next part of the process. Water. Only use distilled water. When you make your stock solutions, distilled water. Now, I don't know if you've followed my videos, you know that I started out making my own distilled water, and I have videos showing you how to make your own distilled water. I've had to abandon the idea of making my own distilled water because of the lightning season storms have created colloidals in my water supply. So I can't get those wild colloidals out of my distilled water. So I've had to rely on store-bought distilled water. But the same as you don't have a distilling machine, you're going to have to use store-bought distilled water. This is Walmart water. Now, this is a brand new gallon, and when I start a brand new gallon, I like to check it to make sure that it is actually pure distilled water. You never know. So this is a TDS meter, total dissolved solids, and this will tell me the quality of my distilled water. So I'll put a little bit in there, and I'll put this in here, and I'll hold it here for a few seconds. And yep, 0 parts per million, okay, distilled water. Now, because I actually have a video microscope, I also like to take a brand new sample of distilled water and put it in my video microscope just to check to make sure it's not loaded with a whole bunch of colloidals. I'm over here. I don't know if the camera can pick me up. Zooming in here on this stuff. This is a laser system that let's see, is the camera picking this up? Yeah. This is a laser system that shows you the condition of the water, which is what I use to show you. I'll show you what the colloidals are like. So that's this batch of Walmart water, which isn't bad. I have to tell you the batch that I had, the previous gallon I had was a little bit better, but it isn't bad. Okay, so our water is good now. We've tested it, looked at it in the microscope. And okay, we're going to dump this in here. Might as well dump the test thing in there. And we're going to fill this with 500 milliliters of distilled water. You can use the measurement on the beaker. That's fine. That'll work. It's close enough for what we're going to be doing. And we're going to stick this on this is a stirring machine and a heating machine. It's got a heat probe. Some colloidals I need to heat. We're not heating copper. And I will put the heat probe in there. And this thing is a magnetic stirrer. I drop this little bullet in there, and I'm going to push this button, and it will start spinning around. You can actually see it's spinning around in there. This is a heat shield I made because I have burned myself on this thing numerous times. So I use the heat shield. We're not using heat today, so I don't have to be too concerned about burning myself. So, all right, what we're going to do now, I got the spinning thing going. I'm going to get this up to around 500 RPMs. I mean, if you're using the silver thing, you might need to use, I would highly recommend you use an air pump in there, an aerator to aerate the water. You got to move, with copper, you got to move the water around or you're going to have a lot of waste. So I would definitely, you got to use some kind of aeration in there, bubbles to move the water around, or get a stirrer. I mean, this stirrer was a little expensive, but you can actually get a inexpensive stirrer on Amazon for about $30. Okay, so there we go. We got our stuff moving around. 500 milliliters. I'm going to put that on there. I'm going to put my copper rod in here, right? And I'm going to connect my anode, the negative, okay. And then I'm going to connect, I'm going to put the my anode, my cathode in here, and I'm going to connect that. Okay, now, well, okay, I've moved my rig around to put the current meter in the camera so you guys can see it. All right there. Now, to get copper 1 and copper 2 in one go, we're going to make two processes. First process is we're going to use citric acid, and we're going to drip that in there. And the second process is sodium citrate. So we're going to start with the citric acid. Okay, I'm going to add the thing on here. Now, if you don't have a current meter, what you can do is you could use the amount of drops that I'm going to use as a rough idea. All right. We want to start, when we start this process, I'm going to drip the citric acid in the top of this thing. And we're going to bring it to between 15 and 20 milliamps. So I'm going to put this on, and you immediately see it's drawing current now, 0.23 milliamps. So we're going to take some of this, and we're going to drip this in here, okay? Let's count the drops. 1, 2, 3, 4, 5, 6. See the current meters going up? 7, 8, 9, 10, 11, 12, 13, getting close, 14, 15. 15 drops. It's giving us 15.48 milliamps of citric acid. Now that current is going to change. From this point on, that current will change. It'll go up or down. We're just interested in the beginning part of the process. So we got 15 milliamps, at roughly between 15 and 20 milliamps, and we're going to cook that for 30 minutes. Okay, I had to recharge the batteries in my timer. So I did not have the timer ready, but anyway, it's not going to matter. But you definitely want to time this process, okay? So, there we go. Hit the timer. All right. Now, this is going to go. I'm going to let this cook for 30 minutes. And then 30 minutes from now, we're going to add the sodium citrate. And then start to see some magic happen, okay? So I will see you guys in about 30 minutes. Hello, welcome back. We are at the 30-minute mark. Well, 29 minutes and something seconds. So we're getting ready. We've just been cooking copper 2, cyan, even though you can't see the color, in here, the copper 2 molecule. So we've been doing that for 30 minutes to get that kind of going. So now we're going to switch to, we're going to add sodium citrate, and we're going to start cooking the copper 1 molecule, which will give us green. What's actually going to happen here is we're going to wind up with an amalgam of cyan and green all in one thing. Now, the first thing I'm going to do is change my scale on my current meter to the 200 milliamp scale, because now we're going to add 10 milliliters of sodium citrate, the stuff that we made before, right? So, I'm going to measure out 10 milliliters of this stuff. Yep, there we go. And we're going to pour it. So we don't make a little bit of a mess. Let's use a funnel. We'll pour it right into the solution. And let's see if we get... Now, as you can see, as soon as I've poured this into the solution, I don't know if you can tell, it started to turn color. That's the little bit of magic that happens with this process. The current meter, as you can see, has jumped up to 41 milliamps. And it's going to cook quite fast at this point. So now we're going to cook it for another 30 minutes or until we reach the a darker cyan. So it's going to be about 30 minutes of cooking left for this process. And we're going to be making now colloidal copper 1. We did the copper 2. Now we're going to be doing the copper 1. Well, actually, we'll probably be cooking them both at the same time, but we're adding the copper 2 now. And the copper 1 now with the sodium citrate. So I will see you again in 30 minutes or until this is like just about ready to be done. Okay, welcome back. 58 minutes. This solution, as you can see, is a nice cyanish, greenish color. I shot a picture of it. You can see it there. It's done. 58 minutes. I consider this done. Now, you've seen the laser test, right? I don't know. The laser test on this stuff is very, very faint with the red laser. With the green laser, it's much brighter. But the giveaway, of course, is the color. We got colloidals in there, obviously, because of the color. So this is done. And the next thing that I normally do, right, I pull the power off here, actually. So it stops cooking. 5909. Now, of course, you wouldn't do it, but the next thing that I do is I like to have a look at it in the microscope. So I will take this stuff, draw some out. As you can see, the light color is darker when there's more of it around. When I take this out of the beaker and put it in the small beaker, you can see that the coloring doesn't look so dark. But that's basically how you want your colloidal. So I'm going to take that. I'm going to put that in the video microscope over here. And I will shoot you a picture of what that looks like. Magic of video editing. That here is that video. Straight from beaker to here. You can see it. That's what our colloidal looks like. I showed you a picture of what the water looked like. I'll put it again when we started. All right. And as you can see, we got colloidals in there. Now, our process is finished for the most part, but I want to remind all of you that you must filter your water. Okay, because when you pull these rods out, you're going to have debris that's going to be floating around in here. So you always want to filter your colloidal solution before you dump it into whatever you dump it into. Okay, I have two ways of doing it. I have a funnel, and then I use these K-cup things, and I put that in the funnel. And wow, where's an empty? Here we go. And what I would do is take this and dump this into here, filling that with our colloidal solution. Tell you what, let's do that just for the big finish, okay? So my meter and shit don't fall all over the place. Oh, there it goes. As you can see the black on here? That's copper that got lost, didn't attach itself. To be very honest, that's actually a pretty decent amount of. That's not bad for. I mean, the silver solution does about that much stuff as well. And I'm going to mention this: the copper cathode. Okay, that's the one that was over here that supplies the copper. Becomes oxidized. So after every time that you cook copper, you need to take a piece of steel wool and you need to steel wool the oxidation off of here. And quite honestly, you're going to lose a lot of copper when you do that. But once this cathode becomes completely oxidized, the current is going to be down to 0 and you won't be able to cook your next colloidal. Of course, if this is your first colloidal, it's not oxidized, so you don't have to worry about it. So before you use your copper rod again, you want to clean this with a little steel wool. You can do toothpaste, but I found the toothpaste is not strong enough to get the oxidation off. So that's about finishes my. You can see. I don't know if you can see. We got some debris floating around in here, and all we're going to do is pour it through the filter. This naturally is not going to fit in this little container, but I'm just showing you the complete process from beginning to end. There you go. That's our complete process from beginning to end in the jar, all ready and set to go. If you have any questions and comments, leave them below and I'll get back to you. I'm Hermes. This is Reality Creative Video. Have a great day.